So what a combination is when you've got a selection of objects and you're not worried about the order. So for example, you have 4 of your favorite books, but you just got a brand new shredder for Christmas and you want to try it out, and you want to shred 3 of your 4 favorite books. The order doesn't matter because in the end, they're going to be shredded. So it doesn't matter which one you shred first, which one you shred second, which one you shred third. The order doesn't matter. So when we're looking at our combinations versus permutations, if you chose books 1, 2, and 3, that's the same as if you had chosen book 1, 3, and 2, 2, 1, and 3, 2, 3, and 1, 3, 1, and 2, or 3, 2, and 1. Because all of those permutations of those 3 are the same as one combination, if the order didn't matter. And if you decided to choose 1, 2, and 4, there's 6 permutations that are the same that way. And if you had chosen 1, 3, and 4, there's 6 permutations of that one. Does it make sense that there's always 6 permutations if you chose 3 objects? Because if you chose 3 objects can be arranged in 3 factorial ways. So just like we divided out the repetition of identical objects, we have to divide out the repetition of the ordering if we want to get rid of the order. So what we can do is we can take our permutations. How many permutations are there for P3? And divide out the order. So our permutations and combinations are connected, and the only difference is you're dividing out the order of the objects. So in our first example when we did the dominoes, right, this 13P2 needed to be divided by 2 or 2 factorial to divide out the order of the 2 objects. So our combinations formula, all our combinations formula is our permutations formula divided by however many objects we're selecting factorial. So our permutations formula is here. Our combinations formula is the same with an added r factorial. And with our permutations formula, we almost exclusively use the spaces technique to figure it out. We will use our combinations formula a lot. So when we get something like 5 choose 2, you have 5 objects, you want to pick 2 of them, the order doesn't matter, right? Maybe you've won a prize and there's 5 grand prizes and you win first pick and they say you can pick any 2. And you're like, oh, should I pick the TV and the barbecue? Or maybe the barbecue and the TV? I can't decide. There's someone like, those are the same. You get to keep them both. It doesn't matter the order. So if the order doesn't matter, the combinations formula will be 5 factorial. The 2 factorial will be on the bottom. And it's really easy to remember the formula because the numbers on the bottom always add to the number on the top. So it would be 5 factorial over 3 factorial, 2 factorial. Another way that combinations are written, this 5 choose 2, in some textbooks, you'll see it written that way. For us, we'll use the 5 choose 2. If you're taking IB courses as well, you'll see this other notation. So if you see this in university classes later on, it might be either notation. So let's look at example 1. Have you heard of Keno Lottery? No, probably not. We'll do this one and we'll do Lotto 6. Have you heard of Lotto 649? Okay. So, Keno Lottery, you're choosing 20 numbers from 80. The order doesn't matter. How many different combinations are there? Again, we'll use the formula. Find the choose button on your calculator. And if you do 80 choose 20, you get a very large number. It's 3.54 times 10 to the 18. It's huge. But since nobody knows what Keno is, but people have heard of Lotto 649, because they often advertise, $35 million prize or something exciting like that. How does Lotto 649 work? You pick 6 numbers out of 49. So how many possibilities are there? 49, choose 6. If you go to your calculator and figure that out, nine, 8, 3, 8, 1, 6. Almost 14 million different combinations. Okay? Yeah, it's better than the other one. So in order to win, you have to get all 6 numbers right. The order doesn't matter. But your chances of winning are like 1 in 14 million. However, if that prize is sitting at 40 million, just go to your local bank, say, hey, would you, I think tickets are $2 each. Are they more? How much? They're $4 each now? Oh. Okay, so imagine the prize is like at 80 million, and at $4 each, you go to your bank and say, could I borrow $56 million, please? Because what's going to happen is I'm going to buy every single combination and guarantee that I win Lotto 649. It's true. If you want to win Lotto 649, you can guarantee it. You can buy all 14 million at $4 a pop. Just cost you around 56 million. Just ask the bank. I'm sure they'll be more than happy to give you 56 million to win the lottery. Yeah, they won't look at you like you're crazy. And as long as the lottery is more than 56 million, you're going to be good, unless there's somebody else who also wins and you have to split it. That's not good. Yeah, for the next week, but not for the week that you win. Right? So you could guarantee that you win. Not too bad. Okay, so the questions you can do for this one are 4, 5, and 7.